Hello, good morning, good evening, good afternoon, wherever you are across the variety of time zones that we have people attending from. Before we delve into the topic for the day, I'd like to do a quick sound check. So if you're able to hear my voice, please type a yes in your questions tab so that we can have some confirmation on the audio being great. There's a few confirmations that I'm being audible. Wonderful. Again, a very warm welcome to everybody joining us today. Our webinar titled AI in Healthcare, Ongoing Lessons and Best Practices for Better Outcomes. My name is Saurabh Kumar, and I'm the APJ Marketing Manager here at H2.ai. I'd love to start off by doing a quick introduction of our panelists today. Leading the discussion today will be Niki, who's joining us all the way from New York. Niki is a customer data scientist at H2.ai with a passion for data-driven knowledge. Coming from a PhD on the microscopic universe of biomolecules, Niki is bringing scientific thinking to real-world big data. Niki has experience in healthcare, among other sectors, and loves to work in interdisciplinary teams. Next up, we have SRK, Sudhalai Rajkumar, better known as SRK. He's a world-renowned data scientist and a Kaggle Grandmaster. His work in the NLP space has won him many accolades and possibly one of the largest followings in the data science space. Rohan Rao, he's a machine learning engineer and a Kaggle Grandmaster with over 6 years of experience building data science products in various industries. He's an IIT Bombay alumni and is hailed the world over for his wins in various Sudoku championships. His dream is to make person of interest a reality. Shivam is a data scientist at H2.ai and again a Kaggle Grandmaster. He's a 3 times winner of Kaggle's data science for good competitions and winner of multiple other AI and data science competitions. Shivam has, again, extensive cross-industry and hands-on experience in building data science products. Before I hand it over to Niki, the following are a few housekeeping items. Please feel free to send us your questions throughout the session via slido.com. Joining instructions are right here on my screen. Slido.com, #lessons. This presentation is being recorded. A copy of the presentation will be distributed shortly after the presentation is over. Now, without further ado, I'd now like to hand it over to Niki to kick off the discussion.
Thank you very much. Good morning to everyone from New York. It's a pleasure to be in this panel. We have held a couple of panels previously because of COVID-19, as a response to COVID-19, touching upon very different time zones. So I'm very happy to have the opportunity to now talk to our friends and customers in this part of the world. Can I change escape to share my presentation? I have to change the presenter.
Yes, absolutely. I'll just do it right now.
Okay. So we are thank you. So we're here today because of the COVID-19 pandemic, but even more than that, this pandemic has shown that data science, data modeling can be an invaluable ally in our fight against disease, in this case, against infectious disease. Nothing explains that better, I think, than this quote that I took from Nature by the former World Bank and World Health Organization chief Jim Yong Kim, who I quote, "No one in their field of infectious disease or public health can say they're surprised about the pandemic. What surprised me is just how quickly we gave up on the standard shoe leather epidemiology," and I'm sure here there's no derogatory intention by no means. I'm sorry. My apologies. So by that quote, I wanted to showcase that nowadays, in this pandemic, data science has shown to be an important ally in predicting and helping the health authorities and the authorities with managing the pandemic. And our Kaggle Grandmasters will talk more about this. Being from a experimental scientific background in computational molecular biology. For me, one of the biggest, most interesting things with regards to the data analysis, data modeling, was the comparison of models as statistical versus machine learning models in trying to model the disease and various of the outcomes relating to that. And here, of course, I want to point out, I put an asterisk because I do consider that the divide is not a strict divide. We use in data science all the tools that are best. And here I have a chart just for those who are not so familiar with the division. So it's interesting for me to see models that are based on a scientific prior knowledge of most cases causal knowledge actually doing very well in predicting the disease, and then also seeing various models, more classical machine learning models using a variety of data also being helpful perhaps in different use cases. And with that, I would like to kick it off and ask our Kaggle grandmasters about their experience in modeling COVID-19, the type of competitions they participated. Yeah, thank you.
Okay. Hey, great. Thanks a lot, Niki. So that's a really helpful. So good morning, everyone. So thanks. Good morning, good afternoon, or good evening, everyone, depending on where you are. So thanks a lot for taking part in this webinar. So okay. So I'll start off from a data science standpoint, like about and some of the things that we have worked on, and like say some of the things that I have personally learned. Okay. So so okay. So when we talk about say AI in healthcare, so one of the major lessons that I learned at least from this thing is like screen visible, right? Okay. So one of the major things that I learned from this experience, or like say the AI in healthcare, so one of the very big learning for me personally at least is like say from a data standpoint. So like we all know, so as a AI person, so we all know like how important is data when it comes to any machine learning models or ML model. So but in this case, data is the I mean, so as it's rightly said, say data is the new oil, and like say only if we have good data, then we'll be able to build good AI systems in the first place. So like when this COVID pandemic started, so one of the things that I have come across is like say there weren't good data sets that are available. So data itself is a very big problem. So in the first place, so one of the efforts that IB as part of the H2O has done is to uh, create a repository for data set. So say, as we could see here, so we also have an open source repository called COVID-19 datasets. So where we had collated and put together some of the well-known open source datasets that have been there. So as you could see, like say JHU has done a very wonderful job on collating all these data set at country level for the affected persons at the daily level. So and there is this COVID-19 open research data set that has the information on all the papers that has come in. So and there are a huge number of Kaggle data sets that are available as well. So in addition to some data from Oxford, our data in world. So this repo COVID-19 data sets will give an idea of the different things. So that will I mean, so different open source data sets that are currently available, which we could make use of. But so one big learning, at least from this one, is like say moving forward. So at least currently it seemed to me more like it was not there already, and it's more of an ad hoc thing. So and everyone was trying to put in all the data sets together at the at the end, as in like when the pandemic hit. So one thing or one infrastructure like that we should develop moving forward is like say to gather the data. So both at a from a government standpoint of view, as well as from an organization standpoint of view. So, and at least say there, of course, there are a lot of concerns about data privacy, data security, and also that needs to be taken care of. But only if we have a good data in the first place, then we'll be able to build any kind of a AI system. So that's one of the main key takeaway for me from this exercise. So after that, say just using the data, we have also built some of the tools so to explore some of these data sets. So if you're new to H2O, or like say this tool itself is a quite new. So like H2OQ is a product that we have built to build some AI apps. So like we internally, like for our clients and for some of the organizations and non-profit ones. So like say we build some applications to help them for COVID. So like I'll quickly like show a couple of them. So like our other colleagues will also show a few of them. So this is the tool using it. Say one interesting thing that we uh, saw from this is like say mobility. So like say one thing, like say when some things like the pandemic comes in, so like we need to see like how people move from one place to another place, so that like we could estimate like how the disease spread would be. So this is one area like where we could see. So we have gotten a data set from a third party data provider, and just to see like how people move from one county to another county in US. So this one is like specific to US, but say like we could build such kind of things for other countries as well if the correct data is available. So like say this one shows like how people have moved from like say over time from this particular dashboard is for New York country. Like say this is how the outgoing population from New York City to other counties. Like generally it is huge, and then there is a sudden reduction in March second week kind of thing, and then it fell down a lot. I mean, so basically due to social distancing and other measures that have been put in place. This is with respect to the incoming population. So like we could see in this chart much more clearly. So this is how generally the movements are. So before the pandemic, and like say as soon as the onset of the pandemic, we could see that people moving towards like along the highways to multiple different counties from New York, though the number of people moving has gone down. So like say once the further social distancing measures are in place, like say the number of people moving has come even further down, but we could see that most of the people have settled in different counties. So these kind of things will help assess like say where people have moved from one place to another, so that like this could be helpful in for doing multiple different analysis, like further downstream analysis. So this is one thing. And like say apart from the mobility, we have also created a lot of dashboards, like say to know about things. So and this is one of the dashboards, like say we created for India. So let's say I mean, so there are a lot of good dashboards available. So like I don't want to go into the details of this one, but one thing which as a person, so like is we could do is like we could do a simulation to understand how the progress will be. So like this is some of the things, like say what we have also done some of the modeling part to understand how our predictions are. So and these predictions are like more like a simulations, because like say when we need to do this, so we also have to provide a lot of information, like say how the growth rate would be. So like here, like when I created the dashboard, I need to give the forecast horizon, and like say what is the growth rate, and like how will be the growth rate decay, and what is the decay acceleration kind of things. So like this could be used as a simulation to like say understand how I mean under various circumstances the predictions will be. So like thanks to our colleagues like and Kaggle Grandmasters, Marius, Dimitri, Philip, and Rohan, who has done a tremendous job in like some of the Kaggle forecasting competitions, where they have also gotten us a lot of ideas about how we can go about predicting some of these things. So like yeah, this is mostly what I wanted to say. So and about the model building part, So I would request Rohan to take it forward from here and let's say throw us some light on like how say the model building part can be done for the pandemic situation like this. Thank you.
Thanks.
Thanks, SRK. Hi everyone, this is Rohan here. So I work as a data scientist at H2O. So I'm not a healthcare expert, but I have worked with some customers in the healthcare domain, and recently as part of the efforts of H2O in helping out with the COVID situation, I spent time understanding how best we could forecast some of the elements for COVID, and uh, Kaggle fortunately had objective competitions on this particular forecasting mechanism. So I spent 5 weeks on that. So they had one competition every week for 5 weeks, where the challenge was to forecast COVID-19 metrics for 4 weeks ahead. So I would like to take you through some of the aspects of those competitions. So if you think about just forecasting COVID-19, there are a lot of open questions in terms of even before coming to the modeling part. Uh, it's very challenging to set up the structure of the problem. So while it's primarily a time series based problem, most models and solutions out there would structure it as time series or regression. But I think one of the most primary questions, before even getting to modeling is what is the most important metric or what is the most important target variable that should be predicted? So there are a lot of options, right? So you could either build a model to predict the number of positive cases, or you could build a model to predict the number of deaths or fatalities, or you could predict the number of beds you may require, and so on. So this is, and it is subjective. It could also vary across geographies. So for example, maybe Singapore might want like a specific, let's say number of positive cases may be more relevant for that country, versus let's say another country in Europe, they would want to estimate the number of fatalities or deaths. Maybe some other country may want to get the number of severe cases to understand how many of hospital beds would be required, whereas maybe another country maybe would want to forecast, let's say, the number of testing kits that are required for COVID-19. Right. So there are a lot of different options and structures that could be used. So specifically on the Kaggle competitions, they used the number of positive cases and the number of deaths. Coming to the data set, as SRK mentioned, it's a very new problem, and I think a lot of people, around the world are sort of aggregating, compiling, and sharing these data sets publicly. And it's amazing to see the amount of activity and information being made available. Kaggle gives that platform where you can actually use some of these and implement into the models and sort of verify and try out whether they are useful or not. So as part of the competitions, we had to forecast these metrics for a lot of different geographies. Primarily, so across the 5 weeks, it started with data on the lesser side. So we had to mainly predict at the country level. But at the end of the fourth week and the last week that was launched, the data became much more granular. So we had data of at a state level and even at sort of a city level. So with time, the data is becoming more dense. There is more information available, and there is one particular insight that I found most useful from this competitions. So let me just share that across. I hope my screen is visible. So this is my solution on the competition. And so the other important aspect of modeling is what is the time horizon which is most useful to sort of forecast? Like, is it, the next 3 days? Is it the next 1 week? Is it the next 4 weeks, and so on? And the output of the models and the importance of the features widely differ. So the graph that you see on your screen right now, so this is a model built on predicting just the next day. So if you look at some of the features, it's primarily the lag features and things like the number of days since the first case was observed, the 10th case was observed, and so on. Right? Whereas if you look at, let's say, model 14 is when you are forecasting 2 weeks ahead. So if you look at these variables, it has a mix of the lag variables, as well as it has latitude, longitude, continent, and population. So these are some metadata about the geographies that sort of become important when you are forecasting slightly more long term. And finally, when you are forecasting, let's say 4 weeks ahead, if you look at the top three variables, none of them are the lag variables. So what this signifies is what is happening today in terms of the, let's say, the cases or the deaths. It is not very predictive of, let's say, 4 weeks or 5 weeks ahead. So that is the reason this is still quite a hard problem to model. And iteratively, with every week passing by, with more sort of data coming in, these models are sort of becoming better, smarter, and hopefully with time we should be able to get a really solid model which is able to model these epidemics much better. So one aspect is obviously the time horizon, and the other is some of the very interesting insights that come from these models. So one of the interesting aspects was the lockdown restrictions and mobility. These are very new, and there are very you don't have too much of historic data or data using past epidemics that can be used to model this current epidemic. So that is the reason they are not very powerful predictors. And obviously the life cycle of this particular epidemic significantly differs across geographies. So what we saw in China was very different from what we saw in Italy, which is different from Taiwan, and now which is very different from what we're seeing in Singapore and India. So it's also becoming important to sort of model these individually. So that's sort of the trade-off between having sufficient data versus sort of breaking down the data set into these smaller geographies and modeling them and optimizing them better. So a lot of these model outputs and algorithms that we built, we submitted it on the Kaggle competitions, and it was quite great to see that the H2O team, we were able to finish in the top 5 in each of the 5 competitions. So that was a very objective validation that the work that we are doing and the models that we are building, it is among the top models out there. And we have also integrated a lot of those models into our core platform and ecosystem. So while these models are good to forecast and understand how the pandemic is moving, the other big aspect of it is finally it impacts business. It impacts business in various different forms. So I'll pass the mic to Shivam, where he'll sort of explain some of the impact that COVID has made on different businesses.
Thanks, Rohan. Thanks for sharing very useful insights about the modeling techniques that we have used. And as you rightly mentioned, that COVID is not just affecting the health industry, but there are many second order effects of COVID. And one of the, before I talk about some of the COVID-19 effects, I would like to talk about that all of the techniques that Rohan, SRK share, like what we are essentially doing is we are building our own models to predict and forecast what is likely to happen across different geographies, not just in terms of number of cases, but in terms of other business metrics as well. So I would like to highlight one of the use case that we were doing for an e-commerce company. So now, as we talked about, these the COVID has different effects in different businesses, be it e-commerce, retail, even banks, finance. So what is happening essentially is that supply chains are disrupted. There are so many logistical issues, so many inventory issues that are going to affect due to these COVID cases. And that effect is now clearly visible at different SKU level products, at different customers, at different regions, etc. And now essentially, if as an organization, if we're going to use the previous traditional forecasting models, then we are not likely to get same results. For instance, this graph here shows this black line in this graph is essentially the actual sales of one of the SKU for one of the e-commerce company in Brazil. And what is essentially happening is their previous forecasting models is this blue line, which is forecasting that the sales are not likely to go up during this period. But essentially, the situation is different. There are actually COVID cases, which is this red line. So due to COVID cases, the actual sales have gone up, which is this green line. What it essentially means that now there is a need to incorporate sensing information. Sensing information is essentially more real-time information. And what we did essentially is we created these demand sensing models, which can capture data from real time, and then they can adjust the previous forecasting models so that as a businesses, they can understand what are their effects at daily level, what are their effects due to these COVID cases. There can be other information as well, for example, social sentiment, because every day due to this dynamic situation of COVID, many things can change, and one of them can be Twitter sentiment, let's say. And as a company, as an inventory management or as a supply chain organization, we want to understand how our sales are likely to affect it due to the sensing information. And that's where we created these models, which we call as demand sensing models, which are different from forecasting models. And these models essentially tries to capture the local effects, the real-time effects, and they try to in fact make adjustments by taking these real-time information and makes the predictions better. And then once we have these better models, then as a business organization, they can pinpoint to the effects that they are likely to see. For example, some of the SKUs might have a positive impact on the sales, some of the SKUs might have a negative impact on the sales. Some of them can as high as 500% impact due to COVID. Some of them can have as low as say 10% or so. So the idea here is that COVID situation can be very disrupting for some of the businesses, and demand sensing is one of the way that H2O is addressing these issues. That's where we are building these models specific capabilities so that individual businesses can also get useful insights to optimize their inventories, supply chains, etc. Now, one of the other area that has been very interesting and recently that has came up is the unsecured lending. So lending and mortgage industries likely to heavily affect due to the COVID situation. For example, in case of US, we are seeing a lot of jobless claims. We are seeing a lot of a big spike in unemployment ratio. Now the thing is, due to these signals, due to this real-time information, as a company, will the previous models still say that these companies are likely to default on their loans, or will they be fine? Will there be no effect? So there is a need to augment the previous historical loans data. For example, this data which I'm showing is a historical loans data from Australian bank. And what we essentially did, we augmented it with some of the useful real-time COVID signals. One of the chart that SRK shared was mobility. So we captured that data. What is the mobility percentage change in this particular region? So like some of the regions have as low as 41% change, some of them has 33% change. And then we have COVID signals, like how many COVID cases have happened in this region, cases per population, etc. So now by looking at these real-time signals, again, which are sensing variables, banks and organizations can adjust their previous loans model. And what essentially they can do is they can then compare how their effects are likely to be in different scenarios. So what they, as a bank, they can do is they can run different simulations and scenarios. For example, in scenario 1, their expected loss is likely to about say 6,000, but in scenario 2, it can be slightly lower, $4,800, due to different simulations that they have run. And then they're gonna look at how their loans are likely to get affected due to increase in COVID cases, due to increase in jobless claims, which regions, which states are likely to have more default rate. So interesting point to note here is that these are not traditional models. These are more sensing models, which not just take historical information to learn from the data, but also captures in the real-time information, like how the situation of COVID is changing. And now these kind of dashboards, these kind of results and insights can be very useful for business owners and banks and even the supply chain organizations to understand what optimal steps they can do. Can they focus on particular areas? For example, in case of these loans, can they focus on a particular group and do something, maybe increase or decrease their interest rate, just to ensure that they do not default as such. So that's where COVID is not just affecting healthcare, but the effect can be seen on multiple industries, and there is a need where H2O is directly addressing it to create these more real-time sensing information. And then there are numerous industries. For example, insurance has, there was a report from McKinsey that shared there are about 50 such cases that are likely to affected due to COVID in case of insurance. That's where, as a data scientist and AI expert, we also need to focus on how we are capturing things like drift. Our population that we used to train our models earlier is different from now, which is obviously yes due to COVID. So we may not rely on previous models, past models. So with all the complex techniques, we also need to keep these nuances while addressing these issues as such. So yeah, this is something that I wanted to highlight. I would like to pass to SK.
Great, thank you, Shivam. We have a number of questions that that we'd like to go over. Let's just dive right into them. The first question asks, what are the top healthcare challenges currently being addressed by AI?
Yeah, I think I can take that if that's okay.
Absolutely, yes, go ahead.
Yeah. Okay, so the top healthcare challenge, I think, is actually COVID-19. This is a healthcare challenge, is a societal challenge, is a production challenge, and AI is helping with that. This is also in my introduction. The former chief of World Health Organization acknowledges how now new techniques, modeling approaches are seriously helping with COVID-19, as well as the panelists just explained through their work in H2O and in Kaggle competitions. In the bigger picture, where we were before COVID-19, there are a few fields that actually healthcare was already utilizing AI, and here with healthcare we have to think that it is not only the bedside, the diagnostic side, which of course I do want to talk a lot about. It's an important field, and we need more AI in that area. But we have all the healthcare ecosystem. We have insurance claims. We have ordering, pharmacy, filling orders. And then, of course, we have even more specialized. We have the idea of personalized medicine. That is, we're a little far away from that, but this is a great goal to achieve with AI. We have robot-assisted surgery. They're engineering, mechanical engineering, together with data engineering, are making miracles, as we all see in videos. And of course, robotics in surgery. And now with telehealth, we all became more familiar during COVID-19 with telehealth robotic assisted surgery could definitely enhance that experience. Of course, we have others. Clinical trial participation, it's an important one because of how hard it is currently and how time-consuming it is to perform clinical trials, drug development, and perhaps later on we'll have more questions about that. But I just wanted to give an outline about the various missed appointments, huge use case there. So yeah, there are definitely a lot of problems in healthcare that are being already tackled with AI, could use more, or the opportunity is just there, right, waiting. Thank you.
Thank you, Niki. Before we go on to the next question, I'd just like to point out that we're taking questions on slido.com. If our attendees can go to slido.com and use #lessons, you'll find all the questions that we have received so far, and they're bucketed by themes. And if of course you have more questions, you can enter them there. You also have the option to upvote a particular question. Now let's get the next question up in front of our panelists. How advanced is AI to overtake a physical doctor, or help augment him, make better decisions? There's questions around trust in AI models. Would you like to take a stab at it, Rohan?
Sure. So if the expectation is for AI to completely replace a doctor, to see a world where there are no doctors, there are only AI models and engines that are doing it, I think we're quite far away from that today. But I think AI is adding a lot of value to the entire healthcare process in a lot of different ways. And as a data scientist, the way I see it is AI adds it adds ammunition to a doctor's decision making. So for example, a few years back, let's say it could be either for let's say prescription, or for diagnosis, or maybe even for policy making. The people involved, the healthcare professionals, they would look at few sort of data points or few aspects to make those decisions. But I think AI has given a path where you can see a lot more, different kinds of outputs or data points. And some of these results are now reaching the professionals at a much faster rate. So for example, you could have, let's say, an image, let's say a scanned image or an X-ray image, and you could get, 50 or 100 data points, and the model could sort of pinpoint what are the most important aspects or the outliers of the data. And sort of using that, the doctor can take, better and sort of improve their sort of decision. So I think one of the biggest challenges, and maybe Niki would know better, is the way I see it is accountability. And I don't think humans are really ready for having a complete automated system be accountable for sort of all decisions in the medical domain. So while I think it adds a lot of value and helping hand, I think we are still some time away with like a complete replacement.
Also, Rohan, since you mentioned me, let me add it's exactly as you say it. Let me add as well, my opinion is that it's not even necessary to have complete independence of AI from physician. At this point, and the way, in typical AI fashion, facilitating workflows, eliminating perhaps, if the AI is helping with certain diagnosis or monitoring a patient for predictive purposes, for example, with sepsis, we have this example. A goal could be also eliminate the patients with low risk for the disease, so the physician can focus on the patients that need him more. Obviously, the goal is to have independent AI, but also I want to say that it's not necessary at the initial stages, and this is the approach that seems to be taken by currently approved diagnostic AI by FDA.
Oh, thanks, Rohan and Niki. So yeah, those are very valuable points. So I would also I'll also second both of them, like in saying that I mean, so complete AI-driven medicine is like very far away, at least. So that's what I think. So, but yeah, so there are some real good examples like where AI can help in a lot of places. So Rohan mentioned about the image problem. So like since I'm working on the NLP side, so like one thing, like say NLP, with respect to NLP, is that there are a lot of research papers that have been like coming up in the recent, like with respect to the pandemic. So and like the AI systems are helping the uh, uh, I mean researchers as well as the healthcare experts to go through all these research papers to come up with a faster solution. So for example, say if drug discovery has been taking a lot of time previously because of a lot of mundane processes involved, but like say AI is kind of helping them like accelerate the process kind of thing. So human in the loop AI is what I think like will be there in the healthcare system. So and like a complete AI driven healthcare system is like very far away, as the end Rohan mentioned. Thanks.
And also healthcare is a very sensitive area. It directly is connected to patients' health. So essentially there is a need for real doctors, but AI can definitely help them to get some more insights, maybe more data driven insights, which they can blend with their knowledge and their experiences of years, and then they can make more informed decisions. And then of course there are operational and non-operational sides in healthcare as well. So like if there are a lot of patients coming in, so as Niki mentioned, maybe one initial filter can be developed using an AI which can just rank the individual so that doctors can prioritize. They are not ignoring anyone, they are just prioritizing better. So these type of insights can be helpful for real doctors.
Great. Thank you, everybody. Next question asks, how can AI, technology meet the need for contact tracing while protecting personal privacy during the crisis and thereafter the crisis?
I would like to take a stab on this question. So contact tracing is a very one of the most important needs in this current crisis situation, and some of the countries, including Singapore, has been very focused on contact tracing. But this question is very interesting because one of the prime doubt that every individual has is that are these contact tracing applications models are also incorporating our personal data, and can they be used in some other manner as such. So firstly, we have to look at from a different perspective. Like if essentially the contact tracing can be thought of as a network problem in which every individual is a node, and the goal is to connect these nodes via some idea, via some intuition. So the way some of the countries have been connecting these nodes is one, like Singapore is doing by identifying if the two people are close enough, they are less than 10 meters, then there exists an edge between them. In some other cases, it can be whether those two people are family members or have they met in past 7 days or 10 days. So the idea is that while building this network, we are not capturing the personal information, but rather the usage or the behavior of those nodes or those individuals. And now every node can be thought of as a initial unique identifier which just has an ID of the individual but don't have any other information. And that's why these contact tracing apps needs to be driven by governments, because they are the ones who maintains these government databases, and they work at a unique ID level, make those networks, and whenever they identify a node which is likely to be affected, which seems to be suspicious node, then they can dig deeper and then contact the individual directly via phone, and maintaining the privacy of that individual as such.
So yeah, since it also talks about data privacy, so I mean, so yeah, it's definitely like Shivam has given very valuable points over there, like about the contact tracing apps and data privacy. So like as Shivam mentioned, like governments are taking care of the privacy issues, and things. But say as a whole infrastructure, like as we move forward, so like in general, data privacy or data security is a very very big thing that has been going on, and so like moving forward, we need to build infrastructure so like that where like we need to have good processes on data privacy and data security things, because that will be inevitable for coping up with any future healthcare epidemics or pandemics. So that's one thing which I want to talk. Thanks.
Thank you. Our next question asks us, how are drug databases searched and appropriate drug matches, found as tentative cures using AI for a particular disease?
Okay, great. That's a good question. So actually, like say from a NLP standpoint of view, so like even say in this COVID, so that there has been a lot of tools and a lot of data sets that has been out there, and and we could do some of these things. So so with the advent of NLP, so like say now NLP has grown a lot in the last 2 years, and then especially in the healthcare space, there are some good innovations like BioBird. So BERT is a recent one, state of the art thing in NLP. So and models like BioBird can be used to like search for drugs and in the vast text database to come up with the best solutions. And there are also tools like SciSpacey, so like where we could also do kind of a named entity recognition kind of thing. So or even we can build some things on our own to look at the drug database and get some good results. So from an already existing standpoint, so like to start with, so I've seen a couple of things. So let me share my screen if that is okay.
Yes, absolutely. Just give me 1 second.
Yeah. Yes, great. Thanks. So as you could see, like this is a open research data set that has been put together by Alan A. So like that has the research text on the entire a lot of research papers. And so this, like if you want to do exploration, like this is a card explorer that has been created by Alan A. So like where we could go and search for some of the drugs that have been, I mean, we could key in our related terms and we could see some of the drugs that come up. So this is one thing that is readily available. And but say like if we want to build something for our own data set, and if we want to do something for our own thing, so this is a biomedsanity.com. So this has been built by Andre Karpathy, so he's a well-known figure in ML world. So he has built a very simple system, so which could be enhanced to get a much more complex like say system. So the code is also available in GitHub, so we could have a look at it so and see like how it could be helped to like search the databases and get relevant information from them. So yeah, that's thank you.
Yeah, basically the goal is to yes, and Niki, let me just add one point. So what SRK shared is very useful. So it's a gold mine of all the research papers, journals that have been produced in the past to also show some effects of previous flus, not pandemic essentially, but some disease-like situations. And the goal is to use these contextual similarity model in order to understand, can we identify some similar situation or similar scenario which may be say 10%, 20% aligned with what COVID-19 is, and then by blending all those all those patterns that we have obtained from different journals, different papers, and then come up with possible candidates that can help in the drug discovery process.
Thank you. I only will add very quickly that this is a very important use case of AI for drug discovery, how to actually mine the literature, because drug discovery and with the COVID-19 data sets that our Kaggle grandmasters are working with, this is a Kaggle competition. It's a very important example. So I just want to go one step back and say that together with that, there are many ways we can leverage with machine learning for drug discovery, and we rely on similarly on known information, prior research of known structures. The idea is with the drug, you want to attack a part of the virus and lock it in so the virus cannot attack. This type of interactions, we have an idea of how this works in different viruses. So we try to mine this historical data and the characteristics of the chemicals in the databases you mentioned. So this could be like, all I want to say is that together with the NLP methods, which actually hold great promise for de novo discovery, we do have classification, regression, all these approaches that can lead to drug discovery in general.
Thank you, Niki. Next relevant question we have asks us, how can densely populated countries like India adapt AI in the healthcare industry?
So let me take a shot at that. Being from India, currently experiencing how COVID is impacting us. So I think India is steadily, adapting a lot of different technologies and solutions out there. So, to like quickly sort of just answer that in one statement, I would like to share like a personal experience of mine. So just this week, I ordered some food to get delivered to my house, and in the app it showed me things like it showed me the hygiene score of the restaurant. It showed me the hygiene score of the area surrounding the restaurant. It showed me the freshness of the vegetables used for that dish, and it showed me the real-time temperature of the delivery executive delivering the food. Right? And all this is only possible if the AI system is going really deep into the solutions or the apps or whatever is the use case. And it has now started reaching and touching the end users and customers and people living in different parts of the country. So while there is so much of population, and yes, there are challenges in getting this live, I think there is a lot of progress happening.
Great, thank you, Rohan. The next question kind of targets a particular use case. How can we leverage AI to estimate year-on-year nurses required in a medical unit for a particular year, for a number of years?
So for this type of a use case, where the idea is that we want to predict in a sequential manner what is likely to happen next month, next quarter, next year, and also the results might be very different for different geographies, for different regions. So the goal should be to create hybrid AI machine learning models, which consist of, say, some typical time series forecasting models, which also involves some demand sensing models like that, which incorporates real-time information about different geographies and about some different past data of those geographies. And then also, since this is more like an estimation problem, it cannot be just one number that we give. It needs to be optimized with respect to different constraints. So every region, every hospital, and every, like, say, location may have different constraints, as in there may be some government regulations, there may be some hospital level constraints. So once we have these forecasting and demand sensing model outputs, we should run some optimization techniques, which can be simple linear optimization or which can be complex integer optimization. And then also, because the situation of COVID is something new, we don't know what is likely to happen even after 5 years. We need to also run scenario based modeling in which we can get these results for different scenarios. So by producing these hybrid models, AI organizations and even the healthcare organization can get some sense of what are, say, nurses required year on year for different geographies as such. But again, with a certain confidence level, because all of these models will have some level of noise because of lack of the huge historical data which we don't have. So with a certain noise and confidence, one can predict.
Thank you, Shivam. We have time for one more question before we take a concluding question. This gentleman asks us how to identify features to be used for changing models to make it suitable for making predictions due to the effect of the pandemic. I mean, how can models adapt to the new data, the data that has not been available for the last century? How can we quickly adapt and pivot?
Okay. Yeah, I'll first go first and then let others add on top of that one. So one thing the very first thing even first to understand is to understand the drift in the data as well as in the model. So just first to see how much the data has drifted due to this kind of pandemic situation. So there will be few areas which will be highly heavily affected and few of them be not so much affected. So first understanding the drift, and then if there exists a drift, so then we need to again, so as Shivam also showed in one of the demand sensing apps. So if we are we able to find out any second order interaction that we could use in addition to our existing features that could help in understanding, I mean, so estimating the future model prediction. For example, say if number of COVID cases can be a proxy, and say if that helps in understanding that extra dip that we get in the models or the data part, as in the model prediction part. So that's one thing. Or if you could use the mobility information, so in addition to the existing features to make use of that one. So essentially we need to see some kind of an, if there are some alternative adjustments that we could use in the features to overcome the drift. And yeah, and one more thing would be to see if we could rebuild the model. So probably if we were building models only once or twice a year previously, now due to this situation, if we are not able to find out other features, then we might have to rebuild it much more often. So that's one another thing that comes to top of my mind. But yeah, but yeah, understanding the drift and say taking care of the drift through some of the other features might be one idea. So I will let Rohan and Shivam add, they have some points.
Yeah, just to quickly add to that, from my experience on working with these data sets, I think one very important and useful method is to break down the data across geographies to test features. So for example, there was a new mobility based features that I was trying out. That feature seemed to work for certain countries, didn't seem to work for other countries and geographies. So that helps in understanding sort of which feature you can use with which geography, and it does make a significant difference in different countries or geographies.
Yeah, but also want to add some artifacts from machine learning interpretability can also be used to identify which features are likely to be some of the useful signals for next models. So one way we can do is we can either do the retraining, or the other way is refitting. So if we retrain the same models and see there is a difference in say feature importances or the Shapley values, then it can give some hints as in which features needs to be given more focus and which needs to be tweaked. And if in case of refitting, if we see some new features that are coming up on the top as the one of the most important features, so then they can give a sense of these are the features that we need to focus more as such.
Okay, we are top of the hour, but I'll take one quick question, the closing question. What is the future of machine learning in a post-COVID world? One quick statement from all of our panelists, please.
Perhaps I can start since I started the discussion. Thank you. So the future of machine learning after COVID-19, I think is good. If anything, just the simple thing that digital transformation has been accelerated whenever was not already completed because of COVID-19. We're now attending this webinar via our computers. We are doing our work via computers. We are using models to help all the countries, to help everyone, to help against the pandemic. So I think the future is good for AI.
So yeah, thanks, Niki. So yeah, from a healthcare standpoint of view, so AI will become inevitable, I guess, after the pandemic. So and So specifically there, I feel that there will be more focus towards the data privacy, security, and also like one another very important point which Shivam like slightly touched upon towards the end, explainability. So explainability will also play a major role like in the like post-COVID. So to help the physicians and researchers. Yeah, thanks.
I mean, AI and machine learning will gonna play very, very important role, be it say healthcare use cases of say contact tracing, forecasting, nurses, and or maybe industry specific use cases to help the stakeholders understand some of the effects that they are likely to see. One of the comparison of COVID-19 that almost everyone makes is the 1918 Spanish flu, and one of the difference that time was that this complex level of AI was not available that time. So hopefully this time AI can show its better impact because the levels in AI are completely different, and we may see some different effects in the coming years.
Yeah, and just to sum up all these points, I think when we look at the future and hopefully very soon start living the post-COVID era, I think most of the learnings and when we as a world together be better prepared to tackling these kind of situations, they are all going to be outputs of the ML models and the research and the analysis that has been done today.
Great. Thank you. Thank you everybody for taking the time today on our panel and sharing your insights and experience with us. I'd also like to say thank you to everyone who joined us today. The panel's recording will be sent in an email shortly. Have a great rest of your day. Thank you.
Bye. Thank
Thanks,
you.
sir.
Have a
Thanks,
good day.
everyone.
Bye.